Number 10, find the critical points on f of x equals x cubed minus 12x. Just list them as ordered pairs. You don't have to tell me who's the relative max, who's the relative min, who's the point of inflection. I probably will, but you don't have to. So first thing, we should recognize, hey, this is an x cubed, so I know it sort of looks like this. And I want to find the critical points. Well, you see there's going to be a relative minimum here, a relative maximum here, and then the point where it's sort of the curve, you curve in this way, and then it starts going back the other way. That's like right there, okay? So that will be our point of inflection. The first thing we're going to start with, we're going to deal with, hey, how am I going to find the minimum, relative maximum? Well, you'll notice the tangent line at these points has a slope of 0 at there and there. So what we're going to do is we're going to take the derivative and then set the derivative equal to 0. That's always my first step. Take the derivative and then set it equal to 0 because I'm trying to find, hey, when are you going to be right here? When's it going to have a slope of 0? That'll tell us where this point and this point happen to be. So let's take the derivative. Easy enough. Now set it equal to 0. In other words, when's it going to have a slope of 0? It's going to be at those points. That'll help us find those points. Okay, now again, this takes a while to work with. Now the first mistake, sometimes factor out a 3. You'll get an x squared minus 4 equals 0. Now I can factor that into an x plus 2x minus 2. You could have divided by 3 and just had x squared minus 4 equals 0, move your 4 over, but then realize, hey, there's a positive and negative piece. Either way, we have the x plus 2 is 0 or the x minus 2 is 0. You're going to get negative 2 and positive 2. So we know these occur when x is positive 2 and negative 2. Well, where's negative 2? Well, negative 2 is further to the left, so this is negative 2 some height. I don't know what it is. And this is positive 2 some height. Okay. Board just took a little delay on me. Weird. So the question is, what's the height? Well, plug the negative 2 and the positive 2 back into the original equation. So once we get our x values, we must plug back into that original equation. So here's the original equation. F of x equals x cubed, can't remember, minus 12x. Silly me. So we're going to plug in negative 2 and get our y value, and we'll plug in 2 and get our y value. So we'll do that, and that'll give us our 2 critical points. Negative 2 cubed minus 12 times negative 2. That's negative 8 plus 24 looks like 16. So I know there's a critical point at negative 2, 16. Now for 2, well, 2 cubed minus 12 times 2, 8 minus 24, excuse me, is what? Negative 16. So there'll be one at positive 2, negative 16. Well, isn't that a pretty little set of numbers there flipping on us? Okay, and it makes sense. Notice this is 2, negative 16. Notice how it's lower. And this is negative 2, positive 16, a height of 16. So we know it's up higher. So we've found our relative minimum and relative maximum. Now we need to find this point of inflection, the place where the turning, where it's curving one way and then boom, flips. How do we do that? We take the second derivative, the derivative of the derivative. Now, here was our derivative. So we got to take the second derivative. That means I'm going to get what? 6x minus 0. So it's just 6x. Wow, that was nice and much easier than normal. So the point of inflection is the second derivative, and we set it equal to 0. We just follow sort of the same way we were doing things up above. So we take the second derivative, okay, and we said the second derivative was just 6x, correct? Yes, because bring the 2 down, it's just going to be 6x. We set 6x equal to 0, and x is 0. So I know that occurs at 0 comma something. How do I find the something? I plug it into my original equation. And the original equation was x cubed, too many things. You have them all in front of you. I don't. Minus 12x. Was that the original equation? Yes, it was. And so we just plug 0 in there. We'll continue in red. 0 cubed minus 12 times 0. Amazingly enough, 0. So we know it occurs at 0, 0. There's our point of inflection. Again, you didn't have to tell me it was a point of inflection. You just had to list, hey, 0, 0 is a critical point.